Let's say you need to expose internal services to the internet or access APIs in a remote network. Instead of maintaining multiple public endpoints, you might prefer a single entry point that can authenticate any incoming traffic and route them based on request details, all before they reach your backend systems. ngrok's traffic policy engine makes this all possible. It provides a phase-based, composable way to route, filter, and secure traffic right at the edge. One way that we can use traffic policy is to route requests to specific internal services based on the properties of the request itself. This wildcard endpoint that I've created in my ngrok dashboard handles traffic to multiple internal services. Since ngrok traffic policies are phase-based, we want to create this traffic policy action within our on HTTP request phase. Here we configure a forward internal action that dynamically reads the host name and maps it to the correct internal endpoint, which points to the correct internal service. By just a few lines of YAML, we're able to get clean and dynamic routing. Now, if I try to navigate to my cloud endpoint and I replace the wildcard with the correct service that I want to navigate to, in this case service 1, then I get to my web application, which is serving service 1. If I want to do the same thing with service 2, I just need to replace it in my hostname, and I'm able to route to service 2. Now that we're routing properly, let's add some security with IP restrictions. Using the restrict IPs action, we can control exactly which clients can access our services. We can also define reusable IP policies directly in our dashboard and reference them right here in our traffic policy. In this example, I've added an IP policy that blocks my own IP address. So when I try to access the service, ngrok enforces the policy and denies the request without it ever touching my upstream infrastructure. So if I save that and I try to access my service 1 again, I receive this error from ngrok saying that my request was blocked by an IP restriction. Same thing will happen if I try to go to service 2. Now, let's go even further. What if we want to block traffic that doesn't include an authorization header? With traffic policy expressions, we get full control over conditional logic based on request metadata. Here, I've written an expression to detect when an authorization header is missing from our request. The policy then triggers a custom response action that returns a message indicating that authentication is required to access this service. This kind of logic makes it easy to enforce API access rules directly at the edge. So if I try to access my service again, I get this custom response saying my access is denied because I'm missing that authorization header for my request. With ngrok's traffic policy engine, you're not just exposing services, you're orchestrating intelligent, secure access with minimal overhead. Whether you're building zero-trust architectures, segmenting environments, or just simplifying service ingress, traffic policy gives you precise control at a global scale. Take a look through ngrok's full list of traffic policy actions listed in our documentation. Whether it's for securing your endpoints or manipulating traffic in the ways that you need, traffic policy actions, expressions, and variables give you the control you need to find perfect solutions. Keep building with ngrok and try creating your first traffic policy today.